everyone, another day has come, which means another vlog. So for today's video, it will be a whole lot different because we are not going to tackle makeup videos or anything that has to do with lifestyle and makeup, because today we are going to have a math tutorial. Get your ball pens and notepads because we are going to tackle differentiation rules, higher order derivatives, local maxima and minima, and optimization rules. Are you ready? Because I am ready. Let's get started.
The first derivation rule is the constant rule. So, f of x is equals to c, and the derivation of c is f prime of x is equals to 0, where c is constant. For example, f of x is equals to 6, wherein the derivative of 6 is f prime of x is equals to 0.
The next rule is the power rule. It was stated that if n is a real number, then f of x is equals to x raised to the power of n and differentiable. And f prime of x is equals to n x raised to the power of n minus 1. An example of power rule. So our given is f of x is equals to x cubed. So in our formula, nx raised to the power of n minus 1. So f prime of x is equals to 3x 3 minus 1. So let's simplify it. F prime of x is equals to 3x squared. So that's it.
The next differentiation rule is the combination rule, which has the formula of f prime of x is equals to c multiplied by n x to the power of n minus 1, in which c is the constant and n is the exponent. We call this the combination rule because it is the combination of the constant rule and the power rule. Let's apply the combination rule. For example, f of x is equals to 2x cubed. In our formula, we put here the constant. The constant in our given equation is 2, multiplied by the exponent, which is 3, x exponent minus 1. F prime of x is equals to 2 times 3 is equals to 6. X 3 minus 1 is equals to 2. 6x squared. So our final answer is f prime of x is equals to 6x squared.
Next rule is sum and difference rule. Formula of sum and difference rule is h prime of x is equals to f prime of x plus minus g prime of x, wherein we have two functions. Here is the example of sum and difference rule. So our f of x is equals to 5x cubed. So first, we have to get the derivative of f of x. So f prime of x is equals to derivative of 5x cubed is equals to 15x squared. So get the derivative of g of x. We have g prime of x is equals to 4x. Then proceed. So h prime of x is equals to 15x squared plus minus 4x. So here we have the sum and difference rule. So it is 15x squared plus minus 4x, or 15x squared plus 4x, or 15x squared minus 4x.
Next rule is the product rule. Here, we should have two differentiable functions, the f of x and the g of x, wherein the f of x should be the u and the g of x should be the v. So, in short, u dv plus v du. So, f of h prime of x equals to f of x times g prime of x plus g of x times f prime of x. So that's it. This is the example of a product rule. H of x is equals to the quantity of 5x plus 2 times the quantity of 6x minus 1. So in our formula, it states that h prime of x is equals to the f of x, which is 5x plus 2. 5x plus 2. Then times the g prime of x. G prime of x is 6 plus the g of x, which is 6x minus 1. 6x minus 1 times the f prime of x is 5 times 5. Then we will distribute the derivatives of the g of x and the f of x. So h prime of x is equals to 6 times 5x is 30x plus 6 times 2 is 12. Then plus 5 times 6x is 30x. 5 times negative 1 is negative 5. And then we will combine like terms. 6 times plus 30x plus 30x is equals to 60x. 12 plus negative 5 is equals to positive 7. So 6x plus 7 of x is our answer.
The next rule is the quotient rule. The formula for the quotient rule is h prime of x is equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared, or v du minus u dv all over v squared. Here is an example of a quotient rule. H of x is equal to 3x squared plus 2x all over 5x squared minus 1, wherein u is 3x squared plus 2x and v is 5x squared minus 1. First, you have to copy the v, which is 5x squared plus 1, multiplied by the derivative of u. The derivative of u is 6x plus 2. So minus, copy u, which is 3x squared plus 2x, and then multiplied by the derivative of v, which is 10x, all over v squared. Just copy the v and put an exponent. Next, using the fold method, distribute each term, and then the answer for this is 30x cubed plus 10x squared minus 6x. Minus 2. Since there is a negative sign, you have to distribute it here so that the sign of these terms will be the opposite. So, negative 3x squared minus 2x times 10x all over 5x squared minus 1 squared. So, using the fold method, you distribute each terms, and it will become negative 30x raised to the power of 5 minus 20x squared. And then you combine the like terms, the answer will be negative 10x squared minus 6x minus 2, or all over 5x squared minus 1 squared. So the final answer will be h prime of x is equal to negative 10x squared minus 6x minus 2 all over the quantity of 5x squared minus 1 squared.
So the next differentiation rule is we have the chain rule. So for the formula, we have h prime of x equals f prime of x times g of x times g prime of x. So therefore, h prime of x equals the derivative of the outer function, leaving the inside function alone, times the derivative of the inside function. So we have here an example. H of x equals the quantity of 2x plus 1 squared. So apply the formula. H prime of x equals the derivative of the outer function, which is 2, times leaving the inside function alone, 2x plus 1. So let's apply the power rule, which we have to subtract 1 to the exponent. Then the next process is we have to derive the inner function multiplied by 2. So let's simplify. So it could be 4 times 2x plus 1. Then distribute, use the fold method. Then our answer would be 8x plus 4. So therefore, the derivative of the given h of x equals to the quantity of 2x plus 1 squared is 8x plus 4. So for the final answer, we have h prime of x is equals to 8x plus 4.
Let us move on to the next topic, which is the higher order derivatives. We have here a definition of higher order derivatives. Let us read. Y is equal to f of x is itself a function. Y prime is equal to f prime of x. You can take the derivative of f prime of x, which is generally referred to as the second derivative of f of x, and written f prime prime of x, or f second derivative of x. Also, you can derive the second derivative of the function f of x, which is also called third higher order derivative, or you can also derive the third higher order derivative, which is called fourth, then so on, which is fifth, sixth, seventh, and so on. Let us take a look at our first example in higher order derivative. Example, we have a function of x is equal to 3x squared plus 6x plus 9. First step is we have to find the first derivative of the function. So the derivative of 3x squared is equal to 6x plus the derivative of 6x is 6 plus the derivative of 9 is 0 because 9 is constant. Now that we have the first derivative of the function of x, we have to find the next higher derivative, which is the second derivative. First, we have the first derivative. So the derivative of 6x is 6. The derivative of 6, which is constant, is 0. 6 plus 0 is 6. So our final answer is 6, the second higher order derivative of f of x. That's it. Our final answer is f second derivative of x is 6.
Now we will discuss the maximum and minimum values of the function. As you can see, this is the graph of maximum and minimum. This is y is equals to f of x. In order to find the maximum and minimum of values of a function, we will draw a tangent line. The greater value of y is our local maxima, and the lesser value of our y is our minimum. Let f be a real number or real value function, and let c be an interior point in the domain of f. Then c is called the point of local maximum if there is an h is greater than 0, such that f of c is greater than f of c. For all x in quantity of c times h, c plus h. C is called a point of local minima if there is an h is greater than 0, such that f of c is lesser than f of x. For all x in x minus h and x plus h. The value of f of x is called the local minimum value of x. I will give you the example of local maxima and minima of the function. So first, this is the function. F of x is equals negative 2x squared plus 5x plus 6. First step is we will find the derivation of the function. So f prime of x is equals to negative 4 of x plus 5. Next step is let's make the derived function equals to 0. So negative 4 of x plus 5 equals to 0. And let's find the root. So negative 4 plus x, let's transpose the 5 to the other side. So the 5 is equivalent to negative 5 over negative 4 to cancel the negative 4 of the x and cancel the negative. x is equals to 5 over 4. We have our root 5 over 4 or 1.55. This is our table of values and this is our graph. At this point, we will draw a tangent and this is our local of minimum, which is 9.13. So our local maximum is 1.25.
Let's move on to our next topic, which is optimization. Optimization is the application of derivations. Optimization means utilizing something. So in this lesson, we will utilize functions according to their maximum and minimum values. Now we have here two optimization problems. Number one is find two positive numbers whose product is 81 and whose sum is a minimum. Number two, find the dimensions of a rectangle with a perimeter of 200 feet with an area as large as possible. So we will answer these problems. So our first example is in optimization problems is that the product of unknown two numbers is 81. So we will represent these two unknown numbers as x and y. So 81 is equal to x and y. The product of x and y is 81. And another condition is that the sum of two numbers is minimum, meaning it is small as much as possible. So we will represent that, or we will convert that to mathematical expression. So s is equal to x plus y. Now, this is our reference function and this is our objective function. So we will refer to this function. So the first step is that we will find the value of any variable. So for me, I will find the value of y. So we have here our reference function. So 81 is equal to xy. To find the value of y, we will divide both sides by x. So y is equal to 81 over x. So we are done getting the value of our y variable. Next step is that we will substitute our y variable to our objective function, which is s is equal to x plus y. So here s is equal to x plus the value of y, which we got from our reference function 81 over x. So 81 over x. 81 over x can also be written as 81 times x raised to the power of negative 1. So here we can derive this one. This is our derivation. So we will equate it to 0. So s is equal to 1 plus 81x is the power of negative 1. 81 over x can also be written as 81 times x raised to the power of negative 1. So here, we will find its derivation. So s is equal to the derivation of x is 1. So 1. Negative 1 times 81 is negative 81 x. Negative 1 minus 1 is negative 2. After that, we will equate it to 0. So 1 is equal to 81 x raised to the power of negative 2. From here, we will rewrite 81 x raised to the power of negative 2 to 81 over x squared. So from this equation, we will get the value of x. So we have to cross multiply. 1 times x squared is equal to 81 times 1 is 81. But then this is only x squared. So what are we going to do to get the value of x? So of course we will get the square root of x squared. Square root of x squared. So x is equal to square root of 81 is equal to 9. X is equal to 9. To get the value of y is we will substitute x to our function, to our objective function. So s is equal to 9 plus y. So from here, we can get the value of y. So we will get the product of x and y. So 9 times y, but it is equal to 81. So we can get y by dividing 9y by 9. So y is equal to 9. Our two unknown numbers are x is equal to 9 and y is equal to 9. So our next example is that the given is the perimeter is 200 feet. So we will utilize that perimeter so that we can get an area as big as possible. So what are we going to do? So this is our reference function, which is 200 is equal to 2L plus 2W, which is the formula for the perimeter of a rectangle. And area, the formula for area of a rectangle is length times width. So from here, we can get the value of W. So we will divide this equation by 2. So 100 is equal to L plus W. So from here, we can get the value of W by by transposing it to another side. So W is equal to 100 minus L. So from here, we will substitute this the value of W from the formula of a rectangle. So A is equal to L, the length, times the value of W, which is 100 minus L. So from here, we will use the distribution property. So 100 L times 100 is equal to 100L, and L times minus L is minus L squared. So from this equation, we will derive it, and after the derived function, we will equate it to 0. So the derivation of area prime is equal to the derivation of 100L is equal to 100. The derivation of L squared is equal to 2L, so minus 2L. We will equate it to 0. So 100 is equal to 2L. To get the value of L, we will divide the equation by 2. So L is equal to 50. Now that we have the value of L, we can get the value of W. So from this equation, 100 is equal to L, the value of L is 50, right? So 50 plus W. And then we will transpose the value of L to the 100 side. So 100 minus 50 is equal to W. 100 minus 50 is equal to 50. 50 is equal to the value of W. So our two numbers is 50 and 50. So area is equal to length times width. Since we have the value of W and L, or the length and the width, so 50 times 50 is equal to 2,500 feet square.
That's it for today's video. I hope you learned and enjoyed as much as I do. Let's give credits to my friends. Let's give a round of applause to them. Thank you so much. Thank you. I hope you enjoyed this video. If you did, please give a thumbs up, click the subscribe button and the bell button below. Thank you so much for watching, guys.